Okay, going back to the problem that was uh, we had before, no? Which is a non-series, non-parallel RLC circuit. We can see here in the circuit that the inductor, resistor, and the capacitor are it's not series and it's also not parallel. Okay, based on its configuration. So seeing this one, we have the I right here. This I is your inductor current because it's entering the inductor. So how to solve for the second order differential equation of this circuit? Okay, going back again to our calculation, we will be doing the KVL. So we already did that. Okay, KVL at loop 1. So we have, again, going back, this is a source-free, a source-free circuit. So although the example here is at 12 volts, we will not be considering that. Okay. Okay, so we have 4I times the voltage of your inductor. Of course, this is KVL, so these are systems of voltages. So 4I is a voltage plus VL plus 2 times I minus the IC, which is um, the interacting or the opposite current, no, that is going through the 2 ohms resistor. Okay, so simplifying the equation, we are going to get the value of our current. Okay, so getting the value of our current for I becomes IL plus VL. We know that that is equal to L di dt plus 2 times I minus IC. Okay, so we have 2 IC. Okay, and the 4I plus 2I becomes 6I. So there we have the equation for our loop, and then we will be doing KCL. Okay, take note, class, that the book has already solved this one based on its voltage. So we are solving it based on the current. Okay. So the book has solved this one based on the capacitor voltage. You may want to look it up on how the book solved this one. But for me, I'm going to solve it based on the current. Okay. So I will leave that to you as an assignment to determine how to get the second order differential equation based on the voltage. So again, we have KCL at node A. If I written node A, let's write node A. KCL at node A. So usually for this type of circuit, what actually works is that you loop the other side and then you KCL on a node. Okay, one way to easily solve this kind of problem. So we have our KCL is we have so we have incoming I plus IR plus IC equal to 0. Okay, and we are going to convert this one IR, we are going to convert this one into we get I plus VC over R plus IC. Okay, so we have this, and then we're going to convert it to IN plus 1 over R plus RC integral. So what we will do here is we will decide which I we're going to solve, no? So we can do IL or we can do IC. So it will be depending on which side are we going to substitute. Okay. We can actually substitute this one right here, equation. This is our equation 1, this is our equation 2. You can actually substitute IC from here so that we can get an IL, or we can substitute the IL from here and we can get an IC equation. Or maybe we can do both. We can try both. Okay, let's try this side here. We will get IC is equal to 6 over L. 6 over 2 with 3 IL plus L over 2 L DIC over DIM. Rather, DIM. Okay, so we have this. Or we can do right here. We have IL negative I. If IL is equal to 1 over RC integral of IC dt plus IC. So, which one do you want to substitute? You can choose. You want to get the capacitor current or the inductor current. So, either way, you're going to substitute one of these into the other. Okay, so maybe let's just follow the IL path where we will substitute or this one so that we can get IN. Okay, so we will substitute the equation 1 into the second equation. So negative IL plus 1 over RC integral of 3 IL plus L over 2 DIL over dt plus another IC, which is 3 IL plus L over 2 DIL over dt. So with that, we will simplify. Okay, negative IL plus 1 over RC let's check the R. R is 2. R is 2. C is 1/2. Okay. RC is equal to 2 times 1/2, that's equal to 1. Okay, so we will simplify this one into just 1. Okay, and then we will get the integral of 3IL plus RL is equivalent to 1. So we get 1/2. 1/2 integral of the derivative, we get 1/2 of IL. Okay, you have dp right there. Plus 3IL plus 1/2 DIL over dt. So right here, that's equal to 0. We will combine like terms and then multiply with d over. So we have here 1/2 d square IL over dt square, this one, and we will have this. Okay, so we have 2 plus 5 over 2 DIL over dt plus 3 IL equal to 0. Okay, so more simplify, remove the 1/2, multiply it by 2, we get d square IL over dt square plus 5 DIL over dt plus 6 IL equal to 0. Okay, so this is our second order differential equation solving for the IL. Okay, how about let's do the other side, which is solving for the IC. We will solve the IC, and this one we substitute right here. We get 6 times 1. RC is 1. RC is 1. Because it's 2. R is 2 and C is 1/2. So we get integral of IC dt plus IC plus L is 1. So we have the DIL and dt. We have integral of IC dt plus IC minus 2IC equal to 0. Okay, simplifying, get 6 integral of IC 6 integral of IC plus 6 E plus 6 IC plus integral of derivative of the integral, you get IC plus DIC over dt minus 2IC equal to 0. So combined like terms, 6, get 5 right here. 6 integral of IC dt plus DIC dt 7 minus 2, 5 IC equal to 0. Okay, we derive both sides. We get here is the d square IC over dt plus 5 DIC over dt. Then here is the 6 plus 6. Derivative of an integral is cancelled out. So right here, plus is the same function with a different variable. So that is how you're going to solve source-free, non-series, non-parallel RLC. Okay, so another example class will be this one, no? It's a non-series, non-parallel dual inductor circuit. So this, you will also get a second order differential equation. Okay, so in the book, this is an example in the book, no? But this one was solved using the current, but now for pedagogic reasons, we will be solving it in terms of voltage. So you will know how to solve the current and voltage in the same circuit. Okay. So we will be applying the same method that we did in the previous example. We will be doing loops and KCL. And also this, we will be solving it source-free. So you may wonder why we're solving it source-free. In the next part of our this lecture series, you will learn how to solve circuits, using a method where we are going to be doing the source-free. Okay, so this is how we make calculations easier. So with this, we will be doing KVL, and then this one we will be shorting them for source-free. Okay, KVL. Well, at group 1, we have 3 I1 plus VL1 plus VL2 equal to 0. Then on the other side, we'll be doing KCL at node A. Node A, we get I I is equal to IR plus IL. Now we'll be solving it based on the voltage. Okay. So this one, we're converting it to voltage, I1, IL1. So let's start here first. 3 times L1 integral of VL1 dt plus L1 plus VL1 VL2 equal to 0. And then this one we also convert to integral of VL1 t 1 over L1. Let's just do negativity. Negative plus VL2 over R. R is equal to 1 ohm. Plus 1 over L2 integral of VL2 dt. So same solution plus we can do both VL1 or VL2 just by substituting uh, uh, which equation that you would like to solve. So this one right here, let's remove the, ano, um, we get a VL2 right here now. VL2 is equal to negative 3 L1 integral of VL1 dt minus VL1. And then right here we get, let's integrate, derive first. T, we get negative 1 over L1 VL1 plus TVL2 over TT plus VL2 over L2 is equal to 0. So we get VL1 is equal to L1 dVL2 over dt plus L1 over L2 VL2 equal to 0. So we'll just substitute. Can substitute this, or you can substitute that, and then you will get a second order differential equation. So you may continue this solution na lang tayo.